now we will look at another similar technique to find the rhythms and the waves of that EEG signal. It is called as match filter. Okay? That the match filter, that it can be used when there is a repetition of the same waveform which is exactly the same or very similar. So, only then we can use the match filter, and one of the requirement of the match filter is that we should have the sample or the template of the observation. That means, it is not good enough that to have that knowledge. For example, that if you are an expert, then looking at that waveform you may tell that this is alpha wave, this is beta wave. So, that kind of qualitative description is not enough. In this case, we need those sample values to actually take advantage of the match filter. Okay. The third thing that it is actually primarily used when there is the noise or artifacts. In fact, sometimes the situation could be so the signal is buried in noise. That means, the noise is so much that hardly we can observe the event. But if we have the template of that event stored earlier, which is clean, then in that case still we can find out the occurrence of that event even if it is buried in noise. And this match filter has another name. It is also known as correlation filter. Okay. We will see as we proceed that why this name has come. So, if we take a signal that is x t in the continuous domain, in the frequency that discrete domain we can write x n. If this is the reference signal, that means the event or the waveform that what we are interested in. So, in the frequency domain we can represent that as x f. Now, if we pass this signal x t through a that linear time invariant filter, that is H t, the output would be the convolution of x t and H t, and we write that as y t. Or if we want to describe this phenomena in the frequency domain, then the output y f would be the product of x f and h f. So, this is the description we get here, and here the point to note that if we take that h f, if h f becomes the scaled and conjugated version, okay, of that the input signal, then we get actually maximum output of that y. Okay. So, this k is giving a scaling and this part is giving a delay. So, let us look at how the impulse response would be. That in this case the corresponding impulse response of that the filter h t would be k times x t 0 minus t. So, what we get here, the first thing that it is first of all scaled, then because we have taken the conjugate, so the time is reversed. So, instead of being a function of t, we are taking minus t, and there is a delay, that is t 0. Okay. So, we have actually flipped the signal and then we have taken the delay. So, this is the observation that taking the complex conjugate of the Fourier transform, that what we are getting the flipped version of the signal flipping in the time domain, that instead of x we are getting, it is becoming function of that x is earlier it was function of t, now it is becoming function of minus t. That means, if we have a say waveform like this for the t, if this is the x t, now x of minus t would be just the opposite, it would be something like this. Okay. This direction is minus t. Okay. And that t 0 actually, this delay, this is just to make sure that if we want a causal signal, what we need to do, we need to take this waveform and start from somewhere here from 0 and beyond that. So, for that this delay is introduced. So, that is the main purpose of it. Okay. If that is not a requirement, that t 0 may not be required. So, in case of match filter, we are having a convolution operation with that impulse response h t and the signal in x t, and what we notice actually this is nothing but equivalent to the correlation. The correlation of the two components, okay, because we have already time reversed the signal to create that h t. So, if we take a part of the signal x t that and then we have a match. So, the output would be that our phi x x t, and in the frequency domain if we look at that, we should get that the PhD of that signal. So, what we get in essence, that match filter is also somewhat equivalent to what we are doing as autocorrelation function in the previous case. Okay. Now, let us see that what kind of output we can expect out of it. So, first we take the example of that spike of and wave, this kind of waveform which is a long duration discrete event. We have taken this portion 0.6 millisecond to 0.82 millisecond, that is the occurrence of a spike and wave, and by computing the autocorrelation function, here we could get the peaks which is higher than 0.5, and we can say that spike and wave is present throughout this signal. Now, let us look that how we can construct a match filter out of it. To do the match filter, first we need to take the template. Here we have taken the template, that starting point 0.6 that second, then going up to this part, that here we have given that signal. Next, what we have done to create the match filter, we have time reversed the signal or flip the signal. Now, flipping that signal, by that it should go in the negative side of the x axis. To make it causal, we have moved it in the right hand side, and thereby we have introduced some delay of about 0.22 seconds. Okay. And here is the template we could get for the match filter. Okay. So, with that now we are ready to find out that spike and wave, presence of the spike and wave we can detect that using the match filter. Now, we take that the test case, that is the signal, the channel C3, and visually we get that spike and wave is present there. Okay. In each of these places that we get spike and wave kind of nature, and then slowly it is actually becoming different. Okay. So, a lot of portion that almost starting from 0.2 to 2.2 second, that we have this kind of that repetition of the spike and wave. Now, to get that using that match filter, we are actually computing the output of the match filter. We see that match filter also, it has peaks very similar to the ACF coefficients. Okay. So, they have peaks which are very similar to the ACF coefficient, but there is a small difference. If we look at the ACF coefficient, we see the peaks are starting from the beginning. Okay. So, peaks are starting from the beginning, but when we go for this match filter output, we see that the front portion there is no activity, and there is a delay actually from where these peaks are coming, and that delay is same as that 0.22 second, that delay what we have actually introduced to make the template as causal. Okay. So, actually the output of the match filter is very well that correlated with the output of the autocorrelation function. The only difference is that there is a delay at the beginning, and that delay is also predetermined, that is the delay we introduced to make that template that as a that impulse response of HT, which should be a causal filter. Now, let us look at another such example. Again, we have that spike and wave. In this case, that instead of the same signal, we are taking a different signal, the F3 channel. So, to get actually the presence of that spike and wave, that here we do not have any template, that is taken from the previous one, that we need to go for cross correlation function. Okay. That is the time domain approach that we have taken. So, now if we want to go for that match filter, again we already have the match filter template that is given. So, with the help of that we can actually compute the output of the match filter. Again we get the same kind of peaky nature, this part that we get same kind of peaks. So, we can say or conclude very well that there is spike and wave, that waveform is present in the channel F3, and however, in the front part of it, this part, we see that there is a flat actually response, and again that is that about 0.22 second, that delay that we told earlier, it matches with that. So, if we look at the previous signal, that thing would become clear, that here the delay is by the delay that we have taken to actually create this the template of the match filter. For that the delay has come, or in other word the technique what we call as a match filter, it is nothing but the a different implementation we can say of that correlation filter. Thank you.